So in this problem, we have cotangent of theta given by 12 over 5 and theta lies in the third quadrant. We need to find the value of all the 5 trigonometric functions. So let's begin. So here we are given the value of cotangent of theta. So cotangent of theta is equals to 12 over 5. Now here it's given here that the cotangent is a positive value. So we'll need to first verify whether if this is true or not. For this, we are going to consider our Cartesian plane, which is divided into 4 quadrants. So going in the anti-clockwise fashion, we have first, second, third, and the fourth quadrant. Now there's a mnemonic A, S, T, and C. So A means all trig functions are positive. So all the 6 trigonometric functions are going to be positive in the first quadrant. So in the first quadrant, our angle is from 0 to pi over 2. Then coming to the second quadrant, S means the sine function is going to be positive and the other trig functions are going to be negative. Now since sine is positive, immediately we can say that cosecant, which is the reciprocal of the sine function, that's also going to be positive. Now that means the remaining 4 trig functions are going to be negative. So second quadrant is defined as the angle where we have between pi over 2 and pi. In the third quadrant, we have T. So T means the tangent function. And since we have the tangent functions or the cotangent functions, so these 2 trig functions are going to be positive and other 4 trig functions are going to be negative, and theta is going to be from pi to 3 pi over 2. And finally in the fourth quadrant, our theta is from 3 times pi over 2 to 2 pi. In this quadrant C means the cosine function. So if we have cosine, then we'll also have to consider secant function. So these 2 functions are going to be positive and everything else is going to be negative. Now in the problem, we are given here that we are in the third quadrant. So in the third quadrant, tangent and cotangent are positive. So that is why in the problem itself, the cotangent function is given as a positive value. Now that we have the values of cotangent, so we can also find out the value of a tangent function. So tangent function is the reciprocal of the cotangent function. Reciprocal of cotangent of theta is 5 over 12. So this is the value of tangent of theta. Fine. Now what we'll do, we will use some identity. So we know that 1 plus tangent squared theta, so that's equals to secant squared theta. So this is one identity, and there's another identity which is 1 plus cotangent squared theta, that's equals to cosecant squared theta. Meaning, if we replace the value of tangent theta with 5 over 12 and solve this equation, we're going to obtain the value of secant theta. And if we replace the value of cotangent of theta with 12 over 5, we can obtain the value of cosecant theta. So let's do that. So we have 1 plus, so tangent squared theta means we have 5 over 12 whole squared equals to secant squared theta. And in this case, we have 1 plus cotangent squared theta. So we are going to have 1 plus 12 over 5. So 12 over 5 is the value of cotangent theta whole squared equals to cosecant squared theta. Let's solve this. We have 1 plus, so 5 squared is 25 divided by 12. So 12 squared is 144, which is equals to secant squared theta. So we get 169 over 144. That's the value of secant squared theta. Then cosecant squared theta, we have 1 plus 144 over 25 equals to cosecant squared theta. So we get 21 plus 144 over 25. So that's 169 divided by 25. That's equals to cosecant squared theta. So taking the square root, so secant theta will be plus or minus the square root of 169 is 13 and square root of 144 is 12. Then we also take the square root on both sides. So cosecant theta will be positive or negative. So 13 over 5. Now we are in the third quadrant. So we know that only tangent and cotangent are positive. So remaining values are going to be negative. So secant theta can only take the value negative 13 over 12. And cosecant theta is also going to take a negative value, which is negative 13 over 5. Now that we have the value of secant theta, we can obtain the value of cosine theta. So cosine theta, which is the reciprocal of the secant function. So that means reciprocal of negative 13 over 12 will be negative 12 over 13. Similarly, our sine value, so sine theta, which is defined as the reciprocal of the cosecant function. So cosecant reciprocal of negative 13 over 5 is negative 5 over 13. There, hence, we have successfully obtained the value of all the remaining 5 trig functions. So tangent of theta is 5 over 12. Secant of theta is negative 13 over 12. Cosine theta is negative 12 over 13. Cosecant of theta is negative 13 over 5. And sine theta is negative 5 over 13 whenever cotangent of theta is given over 12 over 5 and our value of theta lies in the third quadrant.